everyone. Today we will be going over systems of linear equations, and we will cover the homework and the solutions to each problem. Let's start with problem one. Problem one is a system of equations, and it states y equals 5x minus 4 and 3x plus y equals 11. We will begin this system by moving the y and x onto the same side. So we would subtract y from both sides of this top equation here. And we would then get y, or sorry, we would get 0 equals 5x minus y, and then minus 4. Now we also want to get rid of this minus 4 here. So we would have variables on one side and whole numbers on the other. And we would do that by adding 4 to both sides to cancel out the minus. So once again, plus 4 and plus 4. So we get change this 0 here to a 4. So we now have converted this top equation into the same format as this bottom equation. And so the y's are equal or opposite in this equation, like these two equations. So they would cancel each other out. So once we put these numbers here, 11 equals 3x plus y. So now what we want to do is add both of these systems here. And as you can see, the y's cancel out because negative y and positive y. And then we get 8x and we get 15. So what we have from this now is x is equal to 15 over, or yeah, 15 over 8. Now that we have that equation, we just plug it back in and solve for the y. And we can do that by using, let's use the top equation here. So y equals 15 over 8 times 5. So times 5 minus 4. That 15 over 8 becomes 60 over 8 because 15, oh, sorry, I did that wrong. It would be 75 over 8. Minus 4. And we could convert 4 into 8 as well. Like make the denominator 4 8 by multiplying it by 8 over 8. So 75 over 8 minus 32 over 8. And what we have here is y equals 43 over 8. So now we have the solutions for both of our variables for the first system of equations. Let's move on now to the second problem. So we have 4x minus 3y equals 7 and 2x plus 3y equals 5. So off the bat, we can see for this system, the y's will cancel out pretty easily since they already are opposites. So we can just get rid of this, cross that out for now. And we have 4x equals 7 and 2x equals 5. So let's make that 6x equals 12 by adding both of the equations. And from that, we have x equals 2. So we have already solved for x. And now we can just solve for y by plugging it back in. Let's choose this top equation over here. So 2 times 2 plus 3y equals 5. So what we want to do is get rid of this 4. Let's just make this 4 here. By subtracting 4 from either side. So we have 3x, or 3y, sorry, equals 1. And now we have found that y is equal to 1 over 3. Let's now move on to the third problem. Sorry about that. Third problem. So in this system of equations, we can see that we have 6x and 3x as well as 2y plus regular y. In this situation, neither of the values are opposites, so we would have to subtract the bottom equation rather than add it. First, let's make the variable values equal each other. So let's make this, we'll multiply the whole bottom equation by 2 to get the 6x to become, get the 3x to become 6x. So let's multiply this by 2 and we get 6x plus 2y equals 16. So now what we want to do from here is we subtract this, we take the top equation and do minus the bottom equation. So parenthesis around this and a negative sign. And then we take this top equation. And so 6x minus 6x, it cancels out. So let's cancel these. 2y minus 2y, once again, cancels out. So we have 0 equals -2, which means this solution is not solvable. So it has no solution. You can just write NA. So what you would call this type of system is when it has no solution, you just say it is an inconsistent system. So now what we want to do is move on to this next problem. Once again, in this particular system, we will take the top equation rather than the bottom one and multiply it by 2 to get the variable values to equal each other. So let's make this into 4x, this into -10y, and this into 2. So now, once again, the y values wouldn't cancel out, and neither would the x if we just add the equations. So rather, let's make this bottom equation negative and subtract. So these two values of x will cancel out, and so will the values of y once again. So we are once again left with a non-solvable solution. So this solution is also inconsistent. Let's move on to the next problem. So for this problem, we can see we have 7x and 5y. So these are not values that we can cancel out, but we do, however, have 4y and -4y, which would cancel each other out. So we can just add these two equations. This cancels. this becomes 12x, and this becomes 24. So 12x equals 24, x equals 2. And then once again, let's just plug it back in. So 14, because 7x, so 14 plus 4y equals 3. So we can just get rid of that 14 and we get 4y equals negative 11 and y equals negative 11 over 4. So we have our two solutions for this problem. Now on to the next one. So we see here that we have to multiply out by these numbers. So this equation would become 3x, and then this would be minus 6, and we just want to get rid of that minus 6 automatically. So let's just add 6 to both sides. So plus y equals 10, because although it's 4 here, we want to add 6 to get rid of this 6. And then same thing for the bottom one. We have 2x and then minus y minus 1, but we just want to get rid of that 1, so let's add 1 to both sides. 2x minus y equals 8. So in this situation, once again, the y's will cancel out once we add. So cancel that. 5x equals 18. X equals 15 over 5. And what we want to do from here is we just plug it back in once again. Let's choose this bottom equation. So we have 32 over 5 because we take 18 over 5 and multiply by 2. Is equal to negative y minus 1 equals to, oh, so we have 32 over 5 from the 2x, and we can just get rid of that by subtracting 32 over 5. So, and to do that, we also must convert the 7 to have a denominator of 5. So we can multiply 7 by 5 over 5. So that 7 becomes 35 over 5. And then let's do minus 32 over 5. Oh, sorry. It is 36, not 32. So what we have now is this side of the equation becomes negative 1 over 5. And then we just have to add 1. So when you add 1 to negative 1 over 5, you just get 4 over 5. And we need to cancel out this negative. So y is equal to negative 4 over 5. Now, once again, from this one, we honestly don't even have to solve. We can see a pattern here. We have 8x and negative 6y and 4x and negative 3y. So we can see that once we multiply this bottom equation by 2, we just all the variable values will cancel out, and once again, we just get NA, so no solution or inconsistent. Oh, sorry. In this specific case, it is actually not inconsistent because in this situation, we also have the same whole number, which like what it equals. So these are the exact same line. So in this case, all the solutions are the same. So you would say it is consistent and dependent. Con let's move on now.